Morning friends, last period we see Huygens construction of spherical wavefront and plane wavefront. Now we have to see phenomenon of reflection, and later on we have to see the phenomenon of refraction. In order to see the phenomenon of reflection of the plane wavefront, consider the plane wavefront AB bounded on two sides by two parallel rays PA and QB. The wavefront is incident obliquely on the plane reflecting surface XY. That means we have a plane wavefront AB bounded on two sides by the two parallel rays PA and QB. The wavefront is incident obliquely on the plane reflecting surface XY. The wavefront is incident at an angle of incidence I. Initially, the wavefront reaches to the point A. As soon as the wavefront reaches to the point A, according to Huygens principle, point A acts as a secondary source of light, sending out secondary wavelets along AR. If T is the time taken to reach the wavefront from B to C, that means if T is the time taken to reach the wavefront from B to C, in the same time the light waves, the secondary wavelets originating from A covers a distance equal to A to D. If T is the time taken to reach the wavefront from B to C, in the same time the secondary wavelets originating starting from A covers a distance A to D. Therefore, we can write AD is equal to BC. If V is the velocity of light in air, then this distance BC and AD is equal to VT. Equation number 8. To find the position of the reflected wavefront, draw the hemisphere with A as a center and radius equal to VT. Now we have to draw the hemisphere. We have to draw the hemisphere with A as a center and radius equal to VT. This is VT. Now we draw the envelope as DC. That is, CD is the envelope to this hemisphere, tangent drawn to this hemisphere, then this tangent gives the reflected wavefront. That means AB is the incident wavefront and CD is the reflected wavefront. Now this is angle of incidence I. Now this is the angle of incidence I again. This is angle of reflection. Angle made by reflected ray with normal is called as angle of reflection. This is the incident ray, therefore this is the angle of incidence. Now we have to consider the two triangles ABC and ADC, from triangle ABC and ADC. From these two triangles, AD is equal to BC is equal to VT. Now the angle B and angle D is equal to 90 degree. ABC is equal to ADC is equal to 90 degree. And the side, that is AC, is common to both the triangles. Therefore, these two triangles are congruent. As ABC and ADC are congruent, therefore their corresponding angles DAC is equal to BCA. Angle DAC is equal to angle BCA. Now from figure, angle A is 90 minus R and angle C, that is BCA, is equal to 90 minus I. This angle is I and therefore this is 90 minus I. Therefore we can write 90 minus I is equal to 90 minus R. This 90 get cancel, we get I is equal to R. Angle I is equal to angle R. And this proves the phenomenon of reflection, that is the angle of incidence is equal to angle of reflection. In the phenomenon of reflection, again incident ray and reflected ray lies opposite to that of normal. MA and NC are the normals at the points A and C. This is the second law. And third law, incident ray, reflected ray and normal at the point of incidence lies in the same plane. That means if we revise this diagram, we have to consider AB is the plane wavefront bounded on two sides by the two parallel rays PA and QB, incident obliquely on the plane reflecting surface XY such as mirror. Initially the wavefront reaches to the point A. According to Huygens principle, as soon as the wavefront reaches to the point A acts as a secondary source of light, sending out secondary waves along AR. If T is the time taken to reach the wavefront from B to C, in the same time the secondary waves from A covers a distance equal to AD. Therefore we can write BC is equal to AD is equal to VT, where V is the velocity of light in a given medium. Now from triangle ABC and ADC, AD is equal to BC is equal to VT, angle ABC is equal to angle ADC is equal to this 90 degree, and AC is common to both these triangles. Therefore from side angle side test, these two triangles are congruent. Therefore the corresponding angle DAC is equal to BCA. But from the geometry of the figure, angle A is equal to 90 minus R and angle C is equal to 90 minus I. Therefore we can write 90 minus I is equal to 90 minus R. 90 get cancel, we get I is equal to R, and this proves the phenomenon of reflection, that is in the phenomenon of reflection angle of incidence is equal to angle of reflection.